nightstand. Okay, like the Shakers probably wouldn't describe it as mighty because the Shakers liked a simple design. The whole purpose of the Shaker style is clean and functional. Which brings me to my first topic, form versus function. Looking at this table, we want to talk about the form and the function of the table. The form is what it looks like. So design features, like if we zoom in and we look at like this dark peg right here, or a simple drawer pull, or even a feature like the tapers on the legs. Those are form features, the things that give it its design, its style, its character. The opposite of that is function, like how does it work? What does it do? So like the legs, keeping the tabletop off the ground, that's a function. The drawer has the function of holding things. The tabletop has the function of placing your cup of coffee on it, for example. Down to how we put the top together, there's a function of the structure of the table. So we notice we have got grain going horizontally and vertically, if we look at it this way. So there's a function to that as well. On the top, we do the cross grain arrangement to keep the board from warping. If we just went with all the grain going this way, the table would make like a smiley face going like that. So we put a cross grain board to hold that grain locked together, and that's the function of those. Also, this dowel right here has a function as well as form. The function is to lock these two boards in place and keep them from pulling apart. Over time, these boards will expand, they will contract, they'll warp, they'll deform. So everything we do in here has to keep that in mind. We want to mitigate that wood movement. Okay, looking at my table, we've talked about this before. We've got three main parts. We've got the top up here. We have the aprons. We've got a side, a back, and a side apron. And we could also put an apron in front if we wanted to get rid of the drawer, just put a fourth apron there. So top, aprons, and then we have our legs. So a total of 9 pieces for a simple table. This one's going to have many more because the top itself has 1, 2, 3, 4, 5, 6 main boards plus 4 more pegs. So that's 10 pieces just to make the top. And that's not counting any joinery that we don't see inside here. When you're building your table, you're going to work off a set of shop drawings or project plans, whatever you want to call them. So we have this. It is a total of 10 pages long, and each page is going to show you some different details. It's really important before you start just to go through and take a look at all of the pages. So we've got an overview page just to kind of give you an idea of what the finished project looks like. We have, I love it when it draws it wrong when I start it. Okay, so here's our overview with dimensions. So it's going to show us like the length of the legs, the overall length. Notice that these are different. So we designed this backwards actually. We knew that we wanted this to be 26 inches tall. So then we took into consideration the thickness of the top when we did our legs. Same thing as we wanted a top that was 16 by 14. But when you build a table, you want a little bit of overhang for a couple of reasons. One, it just looks better. But two, if you had the legs lined up perfectly with the edge, as that wood moves over time, you'll start to see those gaps. By having an overhang, you can disguise that. Okay, this page isn't going to tell us much about how to build my project. I could see on this how big to cut my leg stock, but that would be about it. Okay, we've got one page just on the legs, and this gives us the details we need to make the leg work pieces, right? So up here, we're going to start with a 1.5 by 1.5 wide stock, and we're going to make that 25 1/4 inches long. And then we have this taper here. It looks more complicated than it is. There's really only 2 measurements. We're going to measure down from the top 5.5 inches. And on the bottom, we're going to measure from the straight edge back 7/8 of an inch. And then we're going to make that taper. You don't need to draw that line. We'll just use the taper jig on the table saw to do that. Okay, and on this we can see that we're going to do this on 2 sides. Okay. Up here we can see some of the joinery that's going to happen later. We're not going to cut this at first, but that just gives us an idea of what's coming. And on this, since I don't want to do a separate drawing for each leg, I'm just going to put a note that says the dovetails on the front legs only. Moving on, we've got the leg joinery layout. So we've got our legs cut. They're not all going to be the same because we have this drawer assembly in the front. So I put this right here, just that isometric of the drawer. An isometric drawing is one that's in 3D like that. That's when we do the V and the vertical, when we draw those in class. That just gives you a sense of how that fits in here. So up here, when we start cutting the joinery, I can see on my back legs, I'm going to have just 2 mortises. On the front legs, I can't see it, but I can see the mirror. So right here on this mortise, it's going to go across and meet one on the hidden part there. On the front, where that drawer goes in, this is where it starts getting tricky. Right? We've got a dovetail on the top, and the purpose of the dovetail is to keep those legs from spreading apart. I'm trying to talk with my hands here. It's not working, so you're just going to have to deal with the mouse, okay? So that little V shape right there keeps this board from pulling apart. I'll show you that on a different drawing. On this page, this one gets pretty crazy because now we have these detail pages. And what this is, we've got A, B, and C. And we can see those right here in this drawing. So right here, these are our legs. If I zoom in on this, that's the top view of the leg. It's really hard to put dimensions on that on a piece of paper. So what we do is we make a detail drawing and we zoom out to our A drawing right here. And I can blow this up at a 1:1 scale. So on your paper, that's actual size. The dotted lines are your hidden lines. So those are what you don't see from the top. So like this right here, this dotted line would be this mortise right here. The solid line is one I actually see. So that's that dovetail, and I can see that on the top. That's this line right here. And then I've got this dotted line right here is going to be that mortise right there. You're probably wondering, well, okay, I can see all this right here. What's this extra line right here? Well, when I set up the drawing, I told it to include all of the hidden lines. So what it's showing me is this foot down here. Remember we made this foot 7/8 of an inch? So if we zoom in on this dotted line right here is the size of the foot. And this dotted line right here, sorry, dashed line, is that's that taper line going from the main corner back here. Okay, so there's our detail A. We're going to do this in stages, right? The first thing we'll cut is the taper, and then as we start looking at these, we'll do these mortises. Okay, on the B, we've got two different kinds, B and C actually side by side. We have two different types of joinery we're going to use on this. We've got just a standard mortise and tenon right here. We'll use the panta router on this. That's what those round ends are. We could also do a traditional mortise and tenon with a square end, but this machine that we use actually lets us go a lot faster. And on the B, this is that drawer front showing the side view of that. We saw the top view in A. There's the side view in B. So when we look over here on our detail drawing, this one is a 1:2 scale. So this is actually smaller than this. So if we took this piece right here and laid it side by side with this, it would be a different size. And this is just going to show me how deep to go on that dovetail, 3/4 of an inch. I have a 3.5 inch opening, and then I've got another 3/4 inch long mortise right there. So the best thing to do is when you draw this, just start from the top and work your way down. Everywhere you see a measurement, copy that onto your board. So I'm going to put 3/4 of an inch somewhere. I'm going to take from the front edge back and put a mark on my board. And I'm going to go ahead and translate that all the way down. Another 3/4 of an inch measurement here. I'm going to start from the top and measure down, and so on. Okay, and then the B is just that same leg, but turned 90 degrees, so this is looking at the side. These dashed lines right here, we can see these mortises right here looking at from the side view. This one's pretty simple. We've got a 3-inch tenon from center to center. Sorry, 3-inch mortise. It's going to be a 1/2 inch wide, and what this drawing does not show, there should be a center line mark right down the middle of this, showing me that this is centered. So instead of a center line, we use a 3/4 inch right there. Okay, if I've lost you so far, don't worry. The beauty of video is you can go back and look at this again. I'm also going to show you on the 3D view. We'll walk through it one more time. Okay, this page is showing the aprons. So we've got a back apron, and that's going to be, I'm just going to jump over here and show you. So on the table, that's this apron right here. Okay, we don't have a front apron because, hey, there's a drawer right there. So we need one of these. I'm going to make this, change has been made to a reference design. Yeah, I'll come back to that. So my workpiece is 11.5 inches long, and that's from the end of the tenon to the end of the tenon. The part that really matters is this 10-inch measurement from shoulder to shoulder, right? So from that edge to that edge has to be precise. Okay, if that's too short or too long, then my table doesn't go square. The tenons, this part right here, that can be a little long or a little short. It goes in a pocket. Nobody's going to see it. If it's too long and it bottoms out, we just cut a little bit off. If it's too short, nobody's going to know. It'll lose a little bit of strength, but it's not going to kill the project. Okay. On the next page, same thing. We've got down here our sides, and we're going to make 2 of them. Okay, and switching back to the 3D view, that's this piece and this piece. And they're identical. They're mirror images of each other. If we isolate that, we can see those tenons. So this isn't important because I'll never see this. The part I see is the part that's important. And if I go like that, we can see how it fits together in there. So you can see it doesn't go all the way through the leg. It just goes part way into a pocket there. Moving on. The drawer assembly. Okay, this is the part where some of you might go, whoa, too much. And that's fine. If you want to take the easy way out, all you have to do, instead of a drawer here, just make another assembly. So make the front look like the back. It will be this on the front. So we wouldn't have that top or bottom piece or the drawer. But, you know, you should give it a try. So down here, we've got these isometrics just to give you a sense of where all the pieces fit. So we've got a drawer. We're not worrying about this right now. But what I have is the supports here and here that will hold the drawer. These top pieces, these are finished pieces, so they partly will hold the drawer, but they're also an appearance piece. It's got a form that we want to make look good. This dovetail right here, because it's such a small piece, we don't want to use just a mortise. We could, and if you'd use a mortise, that's totally acceptable, but this will give it a little bit of extra strength because this leg, if I bump that leg, it's going to try to pull itself out of that little tiny pocket. So by having a dovetail, it locks it in. The tabletop, this is another one you could choose to do a different design on. If you want to do just a plain cutting board style tabletop, you totally could. This one is kind of over-engineered for a small table. Really 16 inches by 14 inches is not going to move that much that we need to worry about it. But if I were making a longer table, I would want to do a breadboard style end. And what the breadboard is a cross grain piece. And I'll show you this on the 3D table. So when we're building the top, we just start from the inside out. This middle part is probably going to be bigger than one width of board. So we'll use 2 separate boards, and there's no joinery between them. It's just a butt joint. Okay, and edge to edge is going to give us all the strength we need. So we build this thing up to the size we need, and notice it's got this dado that runs all the way around. Okay, that's going to lock in with this piece right here. So first thing we want to do is we want to build that to 8.5 inches top to bottom. And then I did not give you a length from here to here, so we have to do some math. You've got 2 3/4 here, 2 3/4 here, and 16 there. So you got to do a subtraction problem. I'm not going to tell you what that is. You got to figure that out for yourself. Okay, and then we add a style piece right here. And you can see on this where that little tenon sticks in there if I turn off that board right there. So when I cut this, I'm going to cut a workpiece that is from this extreme edge to this extreme edge, and from there to there. So that board is going to be right here. I can see it here. So there's 2 measurements. That 2 3/4 right there looks like that's the edge of the board, but down here I've got this 3-inch measurement, and that's showing that tab right there. So when I go here, that 3 inches wide is from this face right here to this face right here. Okay, so we're just going to cut it 3 inches wide, then we'll cut all this joinery in. Right, and then those lock in, and what that does is it locks those 2 boards together. Doesn't really matter on an edge-to-edge connection. Same thing on the front. We can lock those edge-to-edge, but now I've got all of this grain going one way, and when that starts to warp, it's going to make a round warpy thing. So we want to put something straight in here. So I've got this groove that runs that full length, and when I put that in, if I hide one of these, not that one, right, I've got this groove right here that's going to lock in that board. See right there? So if this board right here, if that face tries to warp, this board right here is going to say, no, you don't. I got you locked in. You can't go anywhere. Right, so we put that all together, put another one right there. Now this right here we could totally leave. Okay, in fact, you know, we could do just a straight breadboard. I decided to do what's called a saddle joint right here. And this is really misleading with this taper on the bottom. So right here, this is basically, it's a mortise and tenon, or it's called a saddle joint, or you might even call it a box joint, even though it's flat. What we're doing is we want that surface to surface contact. That surface there is contacting the surface of the cross piece. And by locking those two together, we get a super strong joint. What we don't see on here, it looks like it's just two layers, like a lap joint. The top piece here and the bottom piece right there. But if we look at it from the side, if I just say, let's just look at it straight on from the right, now we can see its total thickness right there. I've got this piece down here. And it's actually just a taper we cut on the table saw. Okay, and you can see right here, see where that little peg's going to go? We're going to cut part of that off. So we want to put those pegs in before we do the taper. So I'll plop those in there. You have to have the sound effects, it's just a thing. So there's a form and a function to those pegs. The function is, if I decided to make this without glue, I could just drive those pegs in and leave it and never have to glue this thing. This peg goes through these two cross pieces and it keeps them from pulling apart. It also gives it a form. We're going to use a darker wood for that just to give it a little bit of contrast and a little bit of character. All right, that was a long explanation for the top, but there you go. All right, last page is the drawer assembly. And this is pretty straightforward if you've done a dovetail. We're going to set that up. I'll teach you guys in class how to do this, but basically, this side of the drawer is going to use a dovetail connection. And the reason for this is that when I grab this handle right here and I try to pull it away, it's going to try to pull this front off of the side. By having that dovetail right there, it locks those two pieces together. Now, if you look at it from the side, right here, that dovetail piece, let's see here, this is a better picture, right where we see that on the isometric. If I grab this panel and pull it sideways, without glue, that would slide right out of there. But we're never pulling it from that direction, so that's why we use that on a box. Okay, the bottom of the box, we can see in here, we've got this 1/4 inch gap here, and it does not show the thickness of this bottom panel. It says size dado to match selected bottom material. That's why there's no dimension on it. So if I grab a 1/4 inch panel, I'll put a 1/4 inch dado. If we're using like a 5 mil plywood, then we're going to use a narrower dado to get exactly the same fit on that dado as the thickness of the plywood. That's why there's no dimension on that one. But we are going to lift it 1/4 inch off the bottom of the drawer box. All right, so let's put this all back together here. All right, let's just do a quick walkthrough in the 3D view. So here's my table. We spent a lot of time on the top, so I'm just going to put that away for a minute. And we can kind of see that drawer side assembly. Let's put that away for just a minute and put these guides away. And we're down to the basic structure of the table. This is what holds everything together. So this part has to be rigid. Okay, now we spent some time doing just basic mortise and tenons. You guys have made this assembly right here. Now we're just going to make it on 3 sides. If you wanted to, like I said earlier, you could make a 4th apron right here and connect that. So let's look at why we do this right here. So right now we've got like a C shape. If I were to grab these legs here and here and pull them apart, there's nothing to hold them rigid. So eventually it would weaken these joints over here. So we need something that will hold them together. So we've got this top guide right here. Now I don't need this for the drawer because the drawer is going to rest on those bottom rests. What I do need this for is just to keep these legs from moving apart. Okay, and again, we're going to use that dovetail in there. If I take that off right there, we can see how that locks into that pocket. You might have something where this isn't square. If we do this on a machine, this will actually be rounded, and that's okay because we're going to hide that. So we put that front apron in. We do need something to hold the drawer up, and this one, we could do a dovetail, like a sliding dovetail and fill it, but we'll keep it easy, just a straight mortise right there. You could drill a hole and use a peg as well. So we can put that on the bottom. And remember, when you cut that apron piece for the bottom, it's longer than the space between these two faces. Okay, and then there's a couple other pieces to this, right? If I put my drawer in, it's just going to fall down in that hole. So we need a couple of guides right there. And I stressed over this a whole bunch, like how does this fit in? If I just glue this, it'll probably fall off. So what we're going to do is we're actually going to screw these in. We'll drill a hole right here. It doesn't show it, but drill a hole probably here, and just screw it right into the apron from this side. Do not run your screws from this side. We don't want to see them. Okay. You could just glue that on. It'll probably hold, but you know, why take the chance? So your drawer is going to rest on these guides here, here, and here. And then we've also got a top one because when you pull the drawer out, it's going to tend to want to tip down. As the drawer pulls forward, this guide right here is going to hold the back edge of the drawer and keep it from tipping up. I wish I had a better animation to show you. Okay, so here's our drawer. Let's isolate that. Okay, so just your basic box right here. If you wanted, you could use a box joint right here instead of a dovetail. Those are easier to cut. And you could either do like a blind box joint. And blind just means you can't see it from the front. These are called blind dovetails. A through dovetail we'd actually see from the front, but we don't want to do that. So you could use a box joint here. You could just do a butt joint. It'll probably break. You could go really cheap and do like a pocket screw. So the main thing is when the door is closed, we want to see a nice clean face right there. Okay. The back doesn't matter so much. Okay. And then we've got this panel right here. So let's hide one side of that so we can see how that goes together. Right, so I've got this panel right here, and it's going to fit in this space. And honestly, that dado right there would probably cut across this dovetail. It's on the side, so we won't see it. Okay, and if I can hide the bottom of the drawer, you can see how that fits inside there. So all four sides are going to have a dado cut around. When you cut those, make sure you cut all four pieces at the same time so that cut is identical. Okay, and when you do it, what's going to happen is, it doesn't show it in the CAD, but this corner right here, this is just going to extend out. So this little triangle right in here is going to match that dado. So you'll see a little slot on the end. You could always plug it with a piece of wood, or you could just leave it open because it's the side of a drawer. Nobody's going to see it. Okay, and the last little piece, that knob right there, you could get an off-the-shelf knob, but really, you know what? We have a bunch of wood lathes. Grab a hunk of wood, preferably the same color as the pegs we used in the top. Turn it on the lathe. It's a design of your choosing. I think I did specify a diameter. Yep. So I did specify a diameter, 1 5/8 inch diameter, and 3/4 of an inch thick. So the hunk of wood you're going to use obviously will be bigger than that, so you can hold it in the lathe, but that's the final dimension on that. So there's your Shaker Nightstand. That's kind of what it looks like when you're done. There's your drawings right there. And you're not tied to this. That's the thing. You can make changes to this. As you make changes, though, if you want full credit on this, you do need to show your changes on your drawing. We call that redlining. So take it neatly, write it in red pen, show me what your changes are. If you want to make your drawing bigger, if you want a bigger top, for example, on this page, change these dimensions to match. You will also need to make every other change that affects that. So if I make my table 2 inches longer, that means that apron has to be 2 inches longer, and the legs will stay the same. Those will stay the same. This is the back apron, so this will be 2 inches longer. That's a side apron, so that would stay the same. My front supports would change, so these two apron pieces would be 2 inches longer. My tabletop would be 2 inches longer, so this board, this board, this board, and this board would all change. The side ones wouldn't unless we change also the depth of the table. And finally, the size of the drawer would change as well. Okay. One other thing I did want to show you, I was talking to some woodshop teachers and they said, you know what, when you're doing your drawings, it's a really good idea to color code as you go. And I realized when they said this, you know, I can go here on my Fusion and I can cycle my components. So each component has a different color. So as I'm looking through this, I can see how all my pieces fit. So I know I've got a top piece. If I turn my top off for a second, I can kind of see all these components on the inside, and I can see that this is a different component than this. And I'm going to make those at different times. I can also see all the components on my drawers. So then as you're doing this on your drawing, let's say I'm looking at, let's do the drawer assembly, and I've got some subcomponents within that. I can say, okay, as I'm cutting this, let me go to my drawing, on my drawer assembly, and I'm going to color code what I see on this drawing. So for example, this peach color right here would be that piece there, that piece there, and that piece there. Okay, I also can see the front in this drawing, and the front would be, in this case, it's the dark pink color. So I'd color that right there dark pink, that dark pink, that dark pink, and that dark pink. So if you're having trouble visualizing how these pieces go together, get yourself some colored pencils, crayons, or whatever, and mark up your drawing that way. All right, there we go. There's one very long walkthrough of the Shaker Nightstand. Good luck. Go forth and make a table.